Synthetic division. Let's look at an example of how to use synthetic division to divide a polynomial by a linear factor. For example, let's divide x cubed minus 7x squared minus 7x plus 20 by x plus 4. Now, recall that x plus 4 is considered a linear factor, and synthetic division can only be used when we are dividing polynomials by linear factors. First, write the coefficients of the dividend. Okay, remember the x cubed has a 1 as a coefficient. So let's write the 1, the -7, -7, and 20, which correspond to the 4 coefficients. Then we'll draw a box that's kind of like an upside down division symbol. And second, let's reverse the sign of the number in the linear factor and write it to the left. Okay, so in the linear factor we have x plus 4. We're going to write -4 to the left. Third, bring down the first coefficient. So this 1 is just going to come down underneath the line. Then we're going to multiply the 1 by the -4 and then add it to the next coefficient. So the -4 times 1 is -4. -7 plus -4 is -11. And then we're just going to continue this process through the last coefficient. So -4 times -11 is 44. -7 plus 44 is 37. -4 times 37 is -148. And 20 plus -148 is -128. Okay, in synthetic division, this last term will be the remainder. If it were 0, then our polynomial would divide, then our linear factor is a true factor of the polynomial. There would be 0 remainder. Okay, 37 is the constant, the -11 is the linear term, and the 1 is the quadratic term. So our answer, or our quotient for this problem, is 1x squared minus 11x plus 37, and then using the remainder, minus 128 over x plus 4. And x plus 4 is the linear factor that we were dividing by in the original problem.